Welcome to Complexity Made Simple. My name is Paul Allen. And the subject of today's video newsletter, well, we're going to talk about using different techniques, cause and effect, hypothesis testing or design of experiments to reduce the variability funnel. So there's this theoretical, let's have a look. So reducing the variability funnel. There's this technique, it's a theoretical technique which is about when you look at a problem and you start off the potential causes of your problem. At this point all the x's are always input variables. And of course at this point the number of variables when you have your problem is at the absolute maximum. And one of the things they talk about in Six Sigma is the idea that as we go down the funnel we're going to use different tools to figure out what the hell's going on. Now I've had a question from a viewer, and he's asked me, how do I use hypothesis testing and design of experiments to work my way down this funnel? Well, the first thing I'm going to say to you is really at the top of the funnel here, in this big section, this is all about control. This is all about fixing variables. Think of it like this: if a variable does not move, it cannot hurt you. If it doesn't move, it cannot hurt you. So the first thing you should be doing, usually when you look at your process, usually your process is in chaos. This is multi-causal. This is multi-causal. Many variables are running out of control. Now the way to get this under control is to use cause and effect to identify them, and then to put standard operating procedures in to fix them. What this will do is very quickly reduce the variability, make your process much more easy to understand. That is step one. Now this is going to take you, normally this will take you 3 months. Most companies are in chaos. They do not have the proper resources to control their process, proper maintenance routines. They're not buying the proper raw materials. They're not adhering to proper rules to run and set the machine up. This will take you 3 months to sort this chaos out. That's the biggest part of reducing the funnel for which variables are most important. And then when you get down to this area, now then, they talk about the fact that you could use a t-test. And what a t-test does is it tells you the effect of every individual variable. So in other words, I have 3 variables: time, temperature, pressure. What I could do is test time. What does it do? And I'll use a t-test to tell me that that effect is valid. Then I can check temperature. I can wind on the temperature dial, and I can use a t-test to tell me if that effect is valid. And then the same thing with pressure. So I'm doing one factor. So if you use hypothesis tests on their own, you are typically doing one factor testing. And of course what this would do is it would tell you the key variables and you're getting down into that funnel. However, this is the slowest way to learn how your process works. Having got your process under control, so possibly 50, 60, 70 variables have all been fixed and held constant, what you're now going to do is probably identify eight variables, we'll say, for further examination, for further understanding. What you don't want to do is one factor testing for those 8 variables, because each time you've got to do a statistical sample size, you've got to do a test, and you've got to do a hypothesis test. It is the slowest way to work down this funnel. Now the technique we're going to use to get out of the bottom of this funnel is a DOE. Initially, a screening DOE. I would probably use the Taguchi L12 initially. I can put up to 11 variables in the L12. So I've gone from 100 variables, maybe down to 8 that's important. Then I'm going to use the L12 to find out the 3 or 4 that are absolutely crucial. And once I've done a screening DOE, I will follow it up with a modelling DOE. Usually a 2 to the 3 or 2 to the 4 full factorial. Then what I'll do is I'll use that knowledge from the full factorial to take this result and make it hit the target, make it land somewhere I want it to go. So that's the way we're working down that funnel. Initially, the top of the funnel is just control. Always remember this. If a variable is not allowed to move, it cannot be your enemy. It cannot be the problem. And if a variable doesn't move, don't allow engineers and technicians to walk up to it and swing on the dials. That is unacceptable. That is not control. That's beginning to allow more chaos to come into the process. So get the process under control, adhere to rules, get the chaos out of the process. Then in a nice, controlled, noise-free environment, you can see the signals either from one-factor tests, which I wouldn't recommend, or from screening DOEs and modelling DOEs, and eventually you get the solution, you pop out the bottom there, and you're just left with 3 or 4 absolutely crucial variables that you are controlling. That is how to use DOE and hypothesis testing. And by the way, the t-test is built into the DOE down here. So this t-test, which is crucial, hypothesis tests are crucial to your process understanding. They are built in to the full factorial modelling DOEs. So we are going to use the t-test down here, but we're not going to use them on their own. We're going to use them more efficiently in a full factorial DOE. And that's how you use hypothesis testing and DOE to get down this funnel. But remember, the top of the funnel, the crucial part, everybody forgets this. The crucial part is getting the process under control. You've got to do the hard yards, identify all your variables and fix them. If you do that, you will understand your process and you will make more money.